Alright, in this lesson we are graphing lines using the slope-intercept form of a linear equation. Linear equations have x and or y variables with a power of 1 or 0. That's how you identify an equation as a linear equation. For example, all of these are examples of linear equations. You'll notice that the x and the y has a power of 1 for all of these equations. The fourth equation, 5x equals 6, does not have a y. That would be the equivalent of y to the 0 power. And the last equation does not have an x. That would be the equivalent of x to the 0 power. All right. So these are all examples of linear equations. These would be examples of non-linear equations. First equation has a y to the second power. The second equation has the square root of x, which is the same thing as x to the 1/2 power. The third equation has x to the third power. And the last equation has 3 over x, which is the equivalent of 3x to the -1 power. So these are all examples of non-linear equations. Slope-intercept form of a linear equation is the most useful form to graph a line. The slope-intercept form is y equals mx plus b, where m represents the slope of the line and b is the y-intercept. Slope is the vertical change of a line over its horizontal change, or rise over run. The y-intercept is where the line crosses the y-axis. And then x and y in every linear equation represent points on the line. All right, so for the first example, we want to first determine what the slope is. The slope is the number in front of the x once it's written in slope-intercept form. And the y-intercept is the constant written after the x term in the once it's written in slope-intercept form. So the y-intercept is -2. All right, so the first point we're going to plot is -2 on the y-axis, since that's the y-intercept. And the slope is -2 over 5, so we're going to go down 2 and to the right 5. Draw a line through those 2 points, and we have our graph. Next example, this one is also written in slope-intercept form. The slope, again, is in front of the x, so that's -8 over 3. And the y-intercept is the constant, which is -5. Our first point is going to go at -5 on the y-axis, since that's our y-intercept. And the slope is -8 over 3. However, if we go down 8 units, we'll run out of space and we'll be outside of the graph. So instead of going down 8 and to the right 3, we're going to instead go up 8 and to the left 3. Up 8 and to the left 3 is the same thing as going down 8 and to the right 3. Draw a line through those 2 points, and we have our graph. Next example, this one is also written in slope-intercept form. The slope is -1. The y-intercept is the constant, and there is no constant. That means that the constant is 0, so the y-intercept is 0. Again, our first point goes at the y-intercept at 0. And the slope is -1, so that's -1 over 1. Down 1 unit, to the right 1 unit. Draw a line through our 2 points, and we have our graph. All right, this one is also written in slope-intercept form. However, there is no x term. All right, so that tells us that anytime you have y equals some number, that is the equation of a horizontal line, where the number represents the y-intercept. So all horizontal lines have a slope of 0. This would be the same thing as writing y equals 0x minus 2, where the slope is 0 and the y-intercept is negative 2. So that's just a horizontal line that crosses the y-axis at negative 2. And last example, anytime you have x equals some number, that is representative of a vertical line. All vertical lines have an undefined slope, and the number tells you where that line crosses the x-axis. Every x coordinate on this line is 5, so there is no y-intercept, so you would just enter none for the y-intercept, and your first point would be at 5 on the x-axis, and it's a vertical line that crosses the x-axis at positive 5.